T-cell, Janice, Bavia, Ariella. Is there any?
No questions.
No questions. If there are no questions, then I would continue with the making of the mind map. Okay. For this mind map, I would like to ask Felicia. Felicia, have you made your mind map since the chapter Introduction to Organic Chemistry?
Yes, but it's not yet on an A3 paper. It's still like the scratch version.
Okay, no problem. Can you help me to do annotation? Let me start with alkanes here. What is the next? Alkanes.
CO2.
Let me write here alkenes, and then halogenoalkanes, and then there is alcohol. Yes. Hello, Atta.
Hello, teacher.
Finish, Felicia?
I think there should be another arrow from carboxylic acid to alcohol and from carboxylic acid to aldehyde and ketone.
Carboxylic acid to aldehyde and ketone. Yes. And then?
And then from carboxylic acid to alcohol.
Yeah. And then still one more that we studied in halogenoalkane. Do you still remember that halogenoalkane?
Halogenoalkanes to nitriles.
Yes, nitriles. Okay. Now this is part of the, this is the presentation. This is a direct presentation from some of you. Okay, Felicia already started making the mind map, this one. Okay, this arrangement you can make by your own. It is not necessarily to be the same. The same meaning that alkene, the right hand side of alkene, and then alcohol, carboxylic acid on top. You can make carboxylic acid next to alcohol. This is, I make it on top because the space on the right hand side, this one is not enough. So that's why I make it on top. Okay, now let me ask from Natasha.
Yes, teacher.
Natasha, what is number 1? What is the reagent and the catalyst?
The reagent will be oxygen gas, and catalyst would be nothing.
Yes, correct.
This reaction is combustion.
Yes, correct. So, correct. Natasha is correct. Okay, now number 2. Number 2, let me ask to Sharon Jessica. Yeah, Sharon Jessica, there are 2 methods how to make alkenes become carbon dioxide. Okay, so there are 2. So 2 means there is a and there is a method B. What is the method A? There are 2 ways.
Teacher, why your voice is like robotic?
Or maybe because of the internet connection. Okay, wait, let me change to other Wi-Fi source. Okay. Is it better right now?
Yes, teacher.
Okay. So there are 2 methods. A and B. And can be, we can make A become B, B become A. This, just pick one method. Sharon, Jessica. Alkenes must undergo something to become carbon dioxide. Must undergo a reaction. What is the reaction? Yes. Oxidation. Okay, it is not oxidation, but it is, what is the oxidation? What is the reagent in oxidation? Yes, Sharon, Jessica. The reagent is oxygen. It is called as combustion. Same like alkenes. Alkenes can undergo combustion. And then for this one, okay, for this one, B, do you still remember? Let me ask to Lawrence. Lawrence, do you remember alkenes can become carbon dioxide, but it is not combustion? Do you still remember? It is undergo hydrolysis. What is the reagent and what is the condition? What is the catalyst? Alkenes become carbon dioxide. Yes, Lawrence, do you still remember? Can you recall?
No, teacher.
No. How about Michelle? Michelle, alkenes can become carbon dioxide. What is the catalyst? And what is the condition of the alkenes itself, so that it can become carbon dioxide? You still remember?
Teacher, can I look at the mind map?
Yes, of course.
It's with hot acidified magnet ion.
Yes, correct. It is hot acidified potassium manganate. What is the condition for the alkenes so that the reaction can occur? The alkene must have, this one is structure of alkene. This one R, this one H, and this one H, this one H, and the second one is this one R, this is R, which one? is 1, 2, 3. 1, this is 2, this is the 3. Which one? Which condition of the alkene that when it reacts with acidified potassium manganate will become carbon dioxide? Is it 1, 2, or 3?
It's 1.
It is 1. Yes, correct. So you have to put inside your mind map. Okay. Okay, you have to put inside your mind map how you are going to do it, how you are going to write it. It depends on you. Okay, I cannot control where you should put it, but you have to put it inside. So later on, when you study, you will not forget. Okay, next. Number 3. Okay, number 2 is already. Number 2 is already. Number 3. Number 3, alkenes become alkenes. Let me ask to Hayato. Hello, Hayato. Are you here?
Yes, sir.
Yeah, Hayato. What is the catalyst to make alkenes become alkenes in this number 3? Alkenes become alkenes. Yes, Hayato, do you still remember?
I forgot, sir.
Okay, no problem. Then let me ask to Patrick. Do you still remember, Patrick? Alkenes become alkenes. What is the catalyst and what is the name of the reaction? Yes. There are 2 possible catalysts. There are 2 possible catalysts.
I forgot.
Forget. Okay. Let me ask to Ariela. Yeah, Ariela, alkenes become alkenes. What are the possible catalysts and what is the name of the reaction?
The catalysts are aluminum oxide and zinc oxide. The name of the reaction is cracking.
Yes, correct. So it is called as cracking, catalyst, aluminum oxide and zinc oxide or zeolite. The temperature is around 600 degrees Celsius, 400 until 600 degrees Celsius. Okay, number 3 already done. Okay, now number 4. Number 4, from alkenes become alkenes. Alkenes become alkenes. This is from the before. Okay, let me ask to Eric. Eric, what is the catalyst and what is the name?
I don't remember, teacher.
Okay, that's okay. No problem. How about let me ask to T cell.
Yes, teacher.
Yeah. T cell, do you still remember what is the catalyst and conditions
Um,
for alkenes?
the catalyst,
Alkenes. Yes.
the catalyst is nickel or platinum,
Yes. Correct.
and the process is hydrogenation with the reagent hydrogen into 100 degrees Celsius.
Yes. Correct. So it is correct. And then number 5. Number 5, alkanes become halogenoalkanes. Alkanes become halogenoalkane. What is the name of the reaction? And there are 3 steps involved in the reaction. There are 3 steps involved in the reaction. Let me ask to Nathan Fee. Hello, Nathan Fee. Hello, Nathan Fee. Are you there, Nathan Fee? Okay, then let me ask to Vedika.
Yes, teacher.
Yeah, Vedika, how to make alkanes become halogenoalkanes?
Is it
In
through
this
free
number 5.
radicals?
Yes, free radical
Is it
substitution.
through
Yes. What is the condition catalyst?
is it UV light?
Yes, correct. And the condition?
I don't know, teacher.
Because the condition in catalyst the same. It's UV light. And then what are the 3 steps involved in free radical substitution?
Is it initiation, propagation, and termination?
Yes, correct. What is the characteristic of initiation?
Yes, teacher.
What is the characteristic of initiation reaction? The formation of 2 free radicals.
Free radical.
Yes, correct. What is the characteristic of propagation?
I'm not sure, teacher.
Now, this one, the propagation, the characteristic is the reaction between free radical and a molecule. The product is new molecule and new free radical. Then, Vedika, what is the characteristic of termination reaction?
Is it that a new product is formed and the
Yes, it is the formation of a molecule from 2 free radicals. Okay, thank you, Vedika. Okay, next, number 6. Number 6, let me ask to Bhavya. Bhavya, what is the catalyst condition for alkenes become halogenoalkenes?
A halogen or hydrogen halide is used.
Yes.
And the reaction name is electrophilic addition.
Yes, correct. Then condition and catalyst.
I think there isn't any specific condition.
Yes, there is no specific condition because it can be done at 1 atmospheric pressure and room temperature. There is no catalyst. Okay, thank you, Bhavya. And then this one, next, number 7. Halogenoalkanes become alkenes. Let me ask to Felicia.
Yes, teacher.
Felicia, what is the catalyst for halogenoalkanes become alkenes?
Ethanolic potassium hydroxide.
Yes, correct.
The condition is heat.
Yeah.
And the name of the reaction is elimination.
Yes, correct. Correct. Okay, Felicia, for halogenoalkane elimination, is there any first and second first elimination and second elimination?
No.
No. Yes, there is no. Only nucleophilic substitution for halogenoalkanes, there is SN1 and SN2 mechanism. Okay, thank you, Felicia. Okay, number 7 already. Now, number 8. Halogenoalkanes become alcohol become halogenoalkanes. What are the 3 possible reagents can be used? It is just last week. Nathan V. Hello, Nathan V. Hello, Nathan V.
Yeah.
Yeah, Nathan V. What is the reagent and catalyst for alcohol become halogenoalkanes?
Alcohol to be
Yes.
halogenoalkanes.
Yes. You can refer to the PPT that we had last week.
Hold it.
Yes.
For the reagent that will be a halogen, for example, like for the reagent will be the alcohol itself, and a halogen, for example, like chlorine or bromine. For the catalyst, right?
Yes.
Because the catalyst is all right. According to this, it will simply be KOH somehow.
KOH from alcohol become halogenoalkane.
Oh wait, nah. No. This isn't right.
No, the last slides. The last slide.
Okay. Back to classroom.
What are the reagents, Nathan V?
Reagent for that will be alcohol and alcohol, and also what is it called, and halogen itself, for example.
Halogen itself, are you sure?
Mm-hmm.
No, in the last slide of halogenoalkanes PPT, present PPT, the last slide, alcohol becomes halogenoalkane.
All right, then it appears that I was wrong. So it appears that for alcohol to be a halogen alkane, it would simply require hydrobromine, for example.
Yes, that is one reactant. Can you state other reactant?
it will be ethanol, not methanol, ethanol.
Yes.
Good stuff.
And
Yes.
then
And therefore, we have the catalyst being H2SO4, concentrated H2SO4, and sodium bromide. Bromide, not bromine.
Okay.
Yes.
Okay. The reactions, there are three possible, which is one is hydrogen halide, the second is phosphorus halide, and the last is SO halide. Okay.
Mhm.
So there are
Yeah.
three possible.
Yep.
Okay. Now, next.
Thank you.
Yes, thank you, Nathan Fee. Next, for this one. Number 9. Number 9, halogenoalkanes. Yes,
For the reagents, it's phosphorus halide, SO halide,
and hydrogen halide.
okay, teacher, thank you.
Yeah, you can refer to the last presentation, the last slide on the chapter halogenoalkane.
Teacher,
Yes,
in the last slide, I think the other two reagents are PCl5 and SOCl2.
yes. Now this one POCl is can be called as phosphorus halide because any halide. Like example, the halogenoalkane we want is not chloroalkane, but can be iodoalkane. So it is using phosphorus halide, not using PCl5, because PCl5 is the reagent to make the halogenoalkane.
Okay, teacher, thank you.
Yes, you're welcome.
And
Teacher.
mechanism
Yes.
is nucleophilic substitution.
Exactly.
Sure, thank you.
Substitution, the mechanism.
Teacher, can you repeat the reagent one more time?
The reagents, there are three possible reagents. The first one is hydrogen halide. So X is halide, and then the second reagent is phosphorus halide, and then the third is SO halide. So this one 3 can also, 5 also possible. So the X equals to a halide ion. Okay.
Thank you, teacher.
Yeah. Now number 9. Number 9 is halogenoalkanes become alcohol. Halogenoalkanes become alcohol. This halogenoalkanes become alcohol. What is the reagent and catalyst? Let me ask, wait, let me find the name. Vanessa. Hello, Vanessa.
Teacher.
Yeah, Vanessa, what is the reagent and catalyst to make halogenoalkanes become alcohol? It is using What does it use? Yes, Vanessa. Can you help to find? It is using. What does it use?
Is it potassium hydroxide?
Yeah, potassium hydroxide. Is it alcoholic? Is it ethanolic or using aqueous?
Aqueous?
Yes, correct. Aqueous. And then what is the condition? What is the condition? Hello, Vanessa. What is the condition? The condition is reflux. Okay, the condition is reflux. Okay, so today we are until this part, until alkyl becomes alcohol. We continue again tomorrow for the discussion of this one. Okay, good morning and thank you, students.
Thank you, teacher.
Thank you, teacher.
Yes.
Thank you, teacher.
Yes.
Thank you.
Morning.